Great. I think that we are ready to start. Once again, welcome and thank you for joining us today at the Master of Data Science degree programs webinar. Today we are here to provide you additional information to help you to prepare to the entrance exam for this online degree program from HSE University. And let me introduce our speaker, Anton Gnatenko, Faculty of Computer Science junior researcher. So today we will review one of the demonstration sample examples of the exam to the MDS program. And before we start, just would like to mention a few formal moments. First of all, the recorded version of this webinar will be available in a few days. We will share the link on our website, so you can always review this webinar. Also here in the Zoom, you have the Q&A option. So if you have any questions regarding the problems and issues from sample, you can ask your questions in Q&A feature. Please use this one instead of chat because it will be easier for us to track all your questions. So I think that we can start, Anton.
Yeah, good evening, everyone, or whatever it is time at your place, and thank you, Fatuna, for the introduction. So our plan for today is to consider the 20 problems from the sample variant, which I will solve one by one on our whiteboard. Let me share it with you. So here is our whiteboard, and I will just go on solving problems one by one, and in between problems I will look into the questions and answers tool and try to answer the questions that you have. So if you have any questions regarding problems, please write them there. But I want to mention that I can't really answer any organizational questions, and for these questions you'll have another opportunity to answer to ask them. So we start with the first problem, and it states that Andrew wrote 5 binaries for some reason. So he wrote this number in binary, and then this number in binary, then this, and this. And then he converted 4 of them into decimals. It is not stated which 4, so 1 was left aside, but 4 of them were converted, and he obtained these decimals: 15, 24, 27, and 30. So now the question is, which is that binary which was left aside, which was not converted? So let's try to answer it. So I'll just link the binaries with their decimal counterparts. Like, okay, I see here 15. 15 is 16 minus 1. Now 16 is 2 to the power of 4 minus 1, yeah? And 2 to the power of 4 is 1 in binary, is 1 and 4 zeros. So when I subtract 1 from here, I get just 4 ones in a row. So I find this number, it is 4 ones in a row, and I now know that it is exactly 15 when converted to decimal. So next, I'll just trying to pick the easy ones first. 30 is 32 minus 2. Okay, and 32 is 2 to the power of 5 minus 2. So 2 to the power of 5 is again 1 and 5 zeros. And when I subtract 1, I get 5 ones. And then so when I subtract 1 from it, yeah, I get just 5 ones. And when I subtract another one, I get 4 ones and a 0. Here is it. So next, for example, 24 is 16 plus 8, which is 2 to the power of 4 plus 2 to the power of 3. And I see it here. It was 2 to the power of 4, okay, plus 2 to the power of 3, and I obtain this. So this is exactly 24. And 27, I obtain 27 when I also add 3 to 24. And 3 in binary, so 24 was, as we have just found out, this. And 3 was 1, 1. When I add it, I obtain this binary. Okay. So now the only one left is this. And this is the answer. So I can just type the answer into the special field, which I haven't examined. Here I just write it. Answer 10011. Okay, this is the binary left out because we didn't find any appropriate decimal for it. So let me see if there are any questions. Seems that there are no questions for now, but if you have a question, you can ask it and I can answer like the questions for previous problems sometime in the future. So we move to the problem number 2, okay? In the problem number 2, we are asked to find the value of this expression, 1234 minus 1 minus 2 minus 3 minus 4 plus 1 multiplied by 2 multiplied by 3 multiplied by 4 modulo 9. Modulo means that we want to find the remainder of it, of the value of this big expression when divided by 9. Now, there is a general rule that for any number, let me write this number with digits like d1, d2, d3, some dn. So if we consider this d sub I as digits, then okay, let me give an example. Just use this example instead of general explanation. So this particular number, 1234, is equivalent or has the same remainder modulo 9 as just the sum of its digits. And it's a general rule. Any number when presented in a decimal system with decimal digits has the same remainder when divided by 9 as the sum of its decimal digits. So as we are looking for only the result modulo 9, as we are looking only for the remainder, we can substitute this big number with this small sum because they have same remainders. So I say that it is equal to 1 plus 2 plus 3 plus 4. I substitute this big number with the sum of its digits. Minus 1, minus 2, minus 3, minus 4. I continue to write down the expression. Plus 1 multiplied by 2, multiplied by 3, multiplied by 4. And this equivalence is modulo 9, of course. It's not just the equality in real world, but when we are speaking about the remainders modulo 9, it holds. And here, these guys just cancel out. And what we have is this. So it suffices to find the remainder of this number modulo 9. But this number is very easy to compute. It is, wait a minute. Yeah, it is 24. Yeah, 64, 24, which is modulo 9. It is 18 plus 6. So when we divide it by 9, the remainder is 6. So our answer is 6 here. Okay. So let me see if there are any questions. No questions so far. Okay. So then we move to the next problem. And this problem includes dealing with a graph, with a picture. We are given an equation, y equals 2 over 5 times x plus 4. And we are asked to find the line. It's one of 4 lines here. So one of them is parallel to the line which corresponds to this equation. So the question is, which of A, B, C, D is parallel to the line, I'll write it like this, star, okay? To the line which corresponds to this equation. Yeah, the exam would be, the question was, would the exam be the same complexity as the demonstration? Yeah, I suppose it is supposed to be so. But actually the complexity of the problems will increase from the first to the last. The last problem is a bit more complicated than this one. And I would say that you don't have a lot of time to solve all these 20 problems. So the problems may be simple, but the exam may be still challenging. Okay, so let's try to find the correct line. So the thing is that if we have 2 lines, okay, for example, 2 lines given by 2 equations, then the general rule is that they are parallel. They are parallel if and only if K1 equals K2. Okay, so here we want to find a line for which in its equation its coefficient equals 2/5. And well, you may know that we may consider, for example, let's consider line A. And let's consider the angle between the line A and this positive direction of the x-axis. So this angle can be either acute, straight, or obtuse. Yeah. And the general rule is that it is, so for example, if this line A had some equation of this form, then this angle is acute if K1 is positive, is straight if K1 is 0, and is obtuse if K1 is less than 0. So, and this angle is obviously obtuse, yeah? So for this line, the coefficient is less than 0, while we are searching for a line with a coefficient greater than 0. So the line A is not our answer definitely. And the same holds for the line B, because again, this angle is obtuse. So our only 2 possible candidates are lines C and D, because for line D, the angle is acute, and for line C, the angle is acute. But then, let me draw the line for which the coefficient equals 1. If the coefficient K equals 1, then the line has this particular angle equals to 45 degrees. And if the coefficient is less than 1, then the angle is smaller. If the coefficient is greater than 1, then the angle is larger. And we see that we are searching for a line with a coefficient smaller than 1. Hence, the angle must be smaller than 45 degrees. And the only such candidate is the only line which satisfies this condition is line D. Okay. So our answer here is D. Let me look for questions. Yeah, there is a question about how to prepare for the exam, I believe that there must be the.
Hi.
Okay.
As to the question, yes. So actually, there is an entrance exam program on our website, and I published the link to our web page. And also, there are several samples, so you can review them to prepare. And if you have any additional questions, you always can email us at mgs@hse.ru. So,
thank you, Fortuna.
General.
Yeah, answer is D. Is it crucial to write all this? Well, at the actual exam, you will have, it will be computers based, yeah, and you'll have only the field for the answer. So you will not have to provide any, and you can't provide any solutions, like written solutions to the exam committee, yeah. Your answer will be just a number or a letter or something, or a string of symbols, but you provide only the answer. So of course, all the thing I'm writing and explaining here is just to explain to you how to solve the problem. And on real exam, the only thing you provide is the answer. Yeah, so if you look at the picture and you immediately know the answer, you just type in D and press enter and move to the next problem. That's fine. Nobody will ask how you solve it. So I believe we can move to the next problem, which is 4. And here we are given an equation, but not a usual equation. It is an equation over binaries. Let me write it out. Okay, so, and the question is to find the value of x in binary. So I would just compute, like if I were you, I would just compute everything I see here. So let us compute the sum of these 3 numbers. I will do it like simultaneously for all 3, but you can do that like one by one. So I do the binary addition here. 2 ones equals 2, which is 1 all, 1 0 in binary. So I write 0 and I move 1 to the next digit. Here again, 2 ones. Okay, let me write it as 1. 2 ones, 0, 2 ones, 0. Here, 3 ones. 3 ones equals 3, which is 1 1 in binary. So last digit is 1, and 1 moves here. Again, 0. And here, 4 ones. 4 ones equals 4, which is 1 0 0. So that is what I write. Okay, and that was, so this is 1. So this is 1 0 0 multiplied by x in binary. This is this number. And when I want to find x, I just need to divide it by this binary by 4. But in binary, it's very easy to divide by 4. If we see the 2 zeros in the end, we just cancel them. Okay, it's just like 4 in binary is just like 100 in decimal system. So we can very quickly divide. I just rewrite this thing, excluding the last 2 zeros. 1 0. This is the answer. So note that I don't place any small 2 here, because on the computer system you can't do that, and the answer is this sequence of 1s and 0s. You don't need to put anything else here. So I hope that it was clear, since there are no questions, but you are free to ask them. Let's move to the next problem, problem number 5. Where we are given a system of linear equations. It's 4x minus 5y equals -1. Let me see if it is a question. No. 7x minus 9y equals 1. The question is to find, actually, what was the question? To find the y, find the solution, and then we take only the value of y and put it to the answer. Yes, so y equals something. So let's find it. I'll just go like they do in the high school. I'll present, so from the first equation, I move this term over the equals and get this. Then I divide by 4 and get this. And then I substitute x with this particular expression in the second line. So I put 7, 5y minus 1 over 4 minus 9y equals 1. And now I only need to solve this equation for y, and I will obtain the answer. Actually, I don't even need to compute the value of x because I am not asked for it. So let's multiply everything by 4 to get rid of this denominator here. It would be 7, 5y minus 1 minus 36y equals 4, which would be 35y minus 7 minus 36y equals 4. Okay, so it's minus y equals 11, which is y equals minus 11. This is the answer. Okay. So there are different ways to solve systems of linear equations, and you can use any you like. Do we require engineering calculator, Hatuna?
So the answer is no, unfortunately.
No, yeah, I don't think you need an engineering calculator. Actually, you don't have any such wild things like, I don't know, sines or cosines here. It's only natural, sometimes integer numbers. Okay, so they can easily be computed just by hand. Problem number 6. We are given a quadratic equation, minus x squared plus 4x plus 5 equals 0. And we are asked to find some strange thing. So let x1 and x2 be roots of this quadratic equation. And we are asked to find this strange expression, the value of this strange expression. Okay, so maybe it is not so strange, but okay, let's try to compute it. There are actually 2 ways of doing it. The first way is to solve the equation directly and obtain the values of roots and substitute them in this expression and then find the value. I would recommend a little bit somewhat smarter way. If you remember the Vieta theorem, or if I pronounce it correctly, anyway, if I have a quadratic equation, a quadratic equation of this form, so where first coefficient equals 1, and I have 2 roots of it, then the rule is that the product of these 2 roots equals c, and sum of these 2 roots equals minus b. Okay, so this is the general theorem, which holds always. And you may see that this expression, if I just add these 2 fractions, it is equal to this. Yeah. So if I rewrite, so I have one coefficient 1 here, but here we have minus 1, so I will rewrite the quadratic equation so that I have 1 before x squared. The roots will be the same, and now I know that the sum of the roots equals minus 4, yeah, minus b, which is 4, and the product of the roots equals minus 5. So it's 40 divided by minus 5, which is minus 8. Okay, and that's all we want to know. We didn't even try to find the roots. We just use the theorem and obtain the value of the expression we are asked to find. There are some questions.
Actually, there are questions regarding the admission, so I will answer in the chat.
Thank you. Yeah, the next problem. Number 7. We are given another quadratic function here. Y equals x squared plus 4x plus a, where a is unknown. A is a parameter here. And we are asked, so we need to find the largest a such that the graph of this function intersects this line. Okay. So depending on the parameter a, the graph of this function will be different, and we need to find the greatest value of a when it intersects this line. So let's us first understand how this graph looks like. Let me draw the coordinate plane. Now, this is a parabola, obviously. And there is a well-known formula to find the coordinate, the x coordinate of the vertex of any parabola. So if you have a parabola of the form x squared plus bx plus c, then the coordinate of the vertex, I'll denote it with x sub 0 here, is minus b over, actually, over 2. Wait a minute. I shouldn't use a here because we use it here. Over 2k's, okay? So we can find the coordinate of the parabola vertex. And for this particular parabola, the coordinate of the vertex is minus 4 over 2. So it's minus 2. So here is minus 2 on the axis x. And the thing is that this parabola, whose branches look upwards, has its vertex somewhere on this line. So it's either look like this, or like this, or like this. I don't know yet because I don't know the value of the parameter a. And depending on the parameter a, this parabola will move up or down along this line, but it will never go right or left. So the actual coordinate, the actual y coordinate of the vertex can be obtained if we just substitute. So we just computed the value of the function at x sub 0, which is minus 2 squared. It's 4 minus 4 times minus 2 minus 8 plus a. So it's a minus 4. Okay. So for some a, it will be here. For some a, it will be here. So if we have some a1 minus 4, then a2 minus 4, and so on. And the line that we are looking for, that we are interested in, is y equals minus 1. This line goes here. We can see that as a grows, the parabola goes up. And at some point, when a is sufficiently large, it will not intersect this red line anymore. But for some a's sufficiently small, it will intersect it. And the very last time when it intersects the red line is when its vertex is here. So we know that its vertex is here when a minus 4, sorry, the coordinate of the vertex equals minus 1. a minus 4 must be equal. So for the a, which is maximal a when the parabola intersects the red line, the a is 3. Okay. So this is the answer. 3. Let me see if there are any questions. No. Good. Problem number 8. Well, we are given some. Is it why not a? Yeah, of course. For any a, so the question asked was, why can't we say that just a is less or equal than 3? Yes, of course. For any a less or equal than 3, the parabola will intersect the line. But we are asked to find the largest such a, and the largest is 3. Okay, so the thing is that, as I said, the answer to any problem is a number or a symbol or a sequence of symbols or a sequence of numbers separated by comma. So the answer must be something that computer can check. So you will always get some question for which the answer is something like that. You can't get the question. You can't be asked to find that, like, the all a's for which the parabola intersects the red line. The problem will be formulated in such a way that your answer will be a number or a pair of numbers or something. So be careful. So you may have obtained, yeah, you may solve this problem correctly, but if you write this to the answer field because you missed this word, then you'll get like 0 for this problem because it's computer check. Okay, so be careful. Can we solve it by? Yes, of course. You can just you can use any solution you like. I just prefer like geometrical solutions. That's why I usually present them, because I think they're more like clear and nice looking. Maybe not in my drawings, but in my head. Okay, so if it's all for this problem, then let's move to the problem number 8. In this problem, we are said that there is some mix of rye and wheat. 1 kilogram of this mix, which is 1,000 grams, and we are said that it consists for 40% of rye. Yeah, and for 60% of wheat. So we are asked how much rye we need to add to the mixture so that it will consist of 50% rye and 50% wheat. So we see that in this mixture, the proportion of rye is smaller, and we are asked how much we must add to obtain like 50-50 mixture. Okay, so we want this. So we want some additional rye. I will denote it by this delta rye. We need to add something to the mixture which will lead to this situation. So let's compute. We had 1,000 grams of the mixture, 40% rye, which means 400 grams rye, and 60% wheat, which is 600 grams wheat. So when we add some rye, we want to the existing rye plus some additional rye to be equal to the amount of wheat. So we want it to be 600 grams. And from here we see that we need to, like, rye is 4,000, and we need to obtain rye is 400. We need to obtain 600. So what we need to add is 200 grams. And that we'll just write this number 200 to the answer, nothing more. Okay. I don't really understand the question. The question is, sorry, as this master's class math. So this webinar is actually about the solution, the solving problems that you get in the exam, and most of them are in math. Yeah.
And if you are asking regarding the program, this program is in data science field.
Okay. So let's move on then to the problem number 9. In this problem, we have two pictures. On the first picture, there is a graph of some function, y equals f of x. While on the second picture, there are 4 different graphs. And we are asked to find the one which is the graph of another function, which looks like this. F of x plus 1 minus 3. So the general rule is, if you have a graph of a function f of x, and if you substitute x with something like f x plus a, yeah, so you had some graph here. Let me just write it, draw it in different colors. So you had some graph here. And you have added something and substituted to x. Then the graph will move horizontally. It will move either right or left. If a was greater than 0, then it will move left by a. Yeah, so it will go something like that. I'm maybe not very good at drawing, but the idea is that your graph has shifted left to the left by a. If the a is smaller than 0, if the a is negative, then it moves to the right. Okay. So here we have 1. 1 is greater than 0, which means that, let me be consistent with colors. 1 is greater than 0, and I write it with the blue color, which means that the graph of this function, when we substituted x is x plus 1, it shifted to the left by 1. So these two graphs are for sure not the graph we're searching for. Yeah, but these two are indeed they look like the original one shifted by 1 cell left. And then we obtain minus 3. So furthermore, if you have a function f of x and its plot, then if you add something positive here, then you shift your graph upwards. If you add something negative here, then you shift your graph downward. Okay? And we have added minus 3. So we have shifted the graph 3 steps down. We have already crossed out these lines B and D. We had only A and C left, and the C is the one which is shifted down by 3. So C is the answer. Okay. So if this is clear, I don't see any questions. Let's go further to the question number 10. And it states that there were 500 students at some university, maybe at High School of Economics, and each student attended exactly 6 courses. So each student, 6 courses. And at each course, there were 300 students attending it. And the question is, what is the number of courses? So we know the number of students, but what is the number of courses? So one way to solve it is the following. We need to somehow connect the students to courses using this knowledge. Let us say that we'll have these bullets here on the left, and they will represent students for us. So there are 500 of them. And there I will draw squares, small squares, which will represent courses. Okay, and there is an unknown number of them, and we want to find it. Let's denote it by X. Each student attends 6 courses. Let's imagine that each student is connected to the course he attends, he or she attends, with a line. So each student attends 6 courses, which means there are 6 lines going out of each student. Yeah, out of each student goes exactly 6 lines, and they go somewhere here. We don't know how they are really connected to the courses, but we know that to each course, so we have kind of span here 6, and here for each course we have 300 incoming lines. This is what is said in the statement. So now the number of lines is of course the same. It doesn't differ if we compute it on the left side or on the right side. On the left side, there are 500 students. Each has 6 lines going out. So the total number of lines is this. On the other hand, let's go to the other side and compute the lines there. There are some X courses, and each produces 300 lines. And this is the equation for X, which we can now solve. 3000 here equals 300 times X, which gives us X equals 10. That's the answer. 10. Okay. Problem number 11. Consider a function, which is a polynomial of degree 3, x cubed plus 7x squared plus some ax minus 4. Can you repeat that question? Only the question. So yeah, the question is how many courses are there? Question here is how many courses are there? So I hope I have answered. So we have this polynomial with, again, with a parameter here, unknown coefficient, but we are given some additional information about the derivative. of this function. We are given the information that this derivative evaluated at x equals -1 is 7. So the question is to find a. Well, does problem 10 require knowledge of combinatorics? Well, it depends on what you call combinatorics. For example, what I'm using here is related to graph theory, but you don't really need to know any sophisticated graph theory theorems to solve it. I would say that this problem generally requires just some, I don't know, basic combinatorial intuition, but no special combinatorial formulas. But we will have a problem closer to the end which requires knowledge of some combinatorial formulas, at least the simple ones. Okay, so it's a good idea to know them. But we will see this problem down the list. And let's continue with the problem 11. Where do I have it? Here. Anyway, so let's first of all calculate this derivative, like the general formula. And if you remember from some previous courses, if I have some x to the power of n, then its derivative is exactly this, including, of course, this subcase. Sorry. And for any constant, c, its derivative is 0. So when and furthermore, if I have like two functions, the sum of two functions, and I want to compute their derivative, then I can use the linearity and just compute the derivatives separately and then add them to each other. So here I can use it. So I have the sum of some functions. I can compute the derivatives separately. So with the first term, by this rule, it's 3 times x squared plus 14x plus a, and that's it. Yeah, and minus 0, if you will, but the 0 doesn't affect the value of the derivative nonetheless. So we now can substitute -1 to this expression, and we know that the result will be 7. So it's 3 times -1 squared plus 14 times -1 plus a is 7, which is 3 minus 14 plus a is 7, from which a equals 18. Yeah, so it would be 21 minus 3, 18. Yeah, that's it. So this problem just checks if you know the basic rules of computing derivatives and all that. Are there any questions? Questions through email. Well, not a question for me. If it is a question regarding this webinar, it's better to type it here.
And regarding the questions via email, we will answer this week. So tomorrow or maybe a day later, I think that we will reply. Thank you for your question.
Yeah, and the recording will be published on the on the official site. Yeah, so
yeah, we also will send you the link on your personal email addresses.
Mm-hmm. And I also think that we will send a link to this whiteboard. So this whiteboard can be accessed separately. Just you can open it and
sure.
Yeah, and switch slides and also. Problem number 12. More numbers, more scary expressions. We are given this very frightening equation. minus 3 over 2 to the power x plus 3 times 9 to the power 3x minus 2 equals 6. And the question is to find the value of x, of course. Well, what I would do, I would just, how do you call it? So you know that, for example, 18 is 2 times 3 times 3. And 9 is just 3 times 3. So I'll use this equalities and just substitute 18 with their special. Or maybe I'll not do that yet. Maybe I'll just use 9 here. So let me see. 18 is 2 times 9, which means that I can rewrite it like this times what was there before. And now these 2 9s can be, like, some of them can be cancelled. So this is exactly 3x minus 4 plus 2. So when we cancel it out, this cancels wholly and this cancels. And here are 2 9s left. Okay, so it's 9 squared left in the denominator. Which I then will, which still equals to 6. But I'll also cancel this for 2. So we had 3x minus 4 here and x plus 3 in the denominator. So we obtain just 2 to the power 2x minus 7. Yeah, when we subtract this power from this power. Basic arithmetic. And here we had 9 squared, and 9 squared was just 2 to the power of 4. So we obtain 3 to the power 2x minus 3 minus 4 minus 7 as well. And here we have 6. But we can combine these 2s and 3s to 6. Yeah, so 6 equals 2 times 3. So our final, very last equation is, is this. I write here 6 to the power of 2x minus 7 equals 6, which means that x to the power of 1. 2x minus 7 equals 1, which means that x equals 4. Yeah, this is the answer. Yeah, I'm actually right. The answer is really 4. Okay, so moving further to somewhat more complicated problems. Of course, it's a matter of maybe taste. Problem number 13. So there were 2 guys, Tom Sawyer and Huck Finn, who were painting a board fence. If you remember the story, they had a big board fence which they had to paint. And we don't know how many. So the statement is that Tom would take 7 hours to complete the work by himself. I will not write it here. So Tom requires 7 hours to complete to paint the fence alone. And Huck maybe would take 8 hours for this task. So, but they work together, so their painting speeds are combined, but they talk a lot. And when they work together, their speed is decreased by 2 or by 3. By 3. Wait. Yeah. So the correct statement is that the board consists of the fence consists of boards. Yeah. Fence consists of boards. Tom takes 7 hours to paint it. Huck takes 8 hours to paint it. And when they paint it together, the speed is decreased by 3 boards per hour. But we also know that working together will require 4 hours to paint the board. So the question is, how many boards was there? So there were some X boards, okay? And we need to find this X. I'll just rewrite everything I written in the words in the form of equations. So Tom has some speed of painting, and it takes him, and I'll denote this Tom speed as VT, V sub T. And when painting with the speed, he paints X boards usually like during 7 hours. It requires 7 hours to do so. On the other hand, Huck has his own speed. And when painting the very same fence, the very same number of boards, he requires 8 hours. When they are painting together, they are painting the very same fence. Their speeds may be added, but we also know that they chat and that the common speed is decreased by 3. But still they can paint the board in 4 hours. This is the 3 equations we have. And we need to find X. So the thing is that there are 3 equations and actually 4 variables, X, VT, oh no, only 3. Yeah, of course, sure. So yeah, so it is now easily solvable. We can just find it out that VT equals X over 7, VH equals X over 8, and that VT plus VH minus 3 equals from here it equals X over 4. So now I will combine this 3. So I will substitute X over 7 and X over 8 in place of VT and VH, and just obtain minus 3 equals X over 4. Okay. So, and this is equation from which X can be easily computed. So if you allow me, I'll just write the answer. So that's a linear equation. You need to add all the fractions, and in the end obtain the answer of X equals 168. So if you want me to do the whole calculation, please let me know through the question and answer section. No questions. Okay. Question number 14. Hannah produces jewelry. It costs, so Hannah produces some jewelry. Okay. For one item, its cost for her, so the cost of producing one item is $10, while the price of one item, the price for which she sells them, is unknown. And knowing that the cost of production of producing one item is $10, and that she makes 24 items a month, we need to find the minimal price. What is the minimal price such that she will earn at least such that the profit will be $360. So we know that the cost of one is $10. She produces 24 per month. Profit each month is desired to be $360. But what must be the price then? So let's say that the price equals X and just makes the equation, just write down the equation. So we have, she produces 24 items and sells each at the price X. So this is the kind of the number of money she gets in the end of the month, but she also needs to pay $10 for the production of each item. There were 24 items, hence 10 times 24 is kind of the cost she needs to pay for the details and for the materials. And we want this to be equal to 360. Well, then 24x minus must be equal to 260 plus 360 plus 240, which is which is 600, which gives us x equals to 25, if I'm right. Something is wrong. Wait. No. Seems legit. Okay. So let me just. Seems that I lost all my abilities to calculate, but you must. Yeah, that's actually correct. But you must make sure that you can compute such things if you spend paper on the exam. Nevertheless, that you will be nervous, like I am now. So this is the answer, okay, 25. Yeah, for some reason it seemed to me surprising. No. If there are any questions about these problems, I'll answer them. But we are really, like, the problems we consider so far were more about computation, and we will have a couple of such problems in the future, but then we'll start with solving some more tricky problems, and I believe it would be more interesting. The problem number 15 is about a robot who lives in the maze, and it has a program which it executes. The question is, the robot starts here at the cell A1 of the maze, and then it executes these problems, this algorithm 20 times. The question is where he will be by the end of the execution. Let us try to execute it. So we start here and we execute the program for the first time. Move right while it is possible. Well, he moves here. Then the next line. Move down while it is possible. I'll do that. Move left while it is possible. And move up while it is possible. So by the time it executes the program robot for the first time, the robot will end up here. Let's execute the program robot for the second time. Again, go right while possible, go down while possible, go left while possible. I can't do that, so it's a wall here. Go up while possible. I'll end up here. That was the second time of executing the program robot. Then the third time. Okay, look. For the third time, again, move right while possible, move down while possible, move left while possible, move up while possible. It seems that we ended up at the very same point where we started. So the same thing will happen if we execute the program for the fourth time, for the fifth time, and for any number of times. So we will, after executing it for 2 times, we end up here, and we will remain here forever. So after executing the program robot for 20 times, we'll still be here at the cell B4. So this is the answer. The answer is B4. Is that clear? So here it is enough just to rigorously execute the program for some time and understand the behavior of the robot, and then you will be able to give the answer straightforwardly. So I didn't execute the program for the whole 20 times. I just noticed that after the second time, it kind of loops and we stay in the same cell. Now the problem number 16. George has $100 in the bank on his account. There are 2 operations he can perform. He can either withdraw $35 or he can put to his account $14. He currently has 0. In the bank, he has 100. The question is, what is the maximal sum that he can take from the bank using only these 2 operations? Well, let's at first just try to produce some sequence of operations. For example, George had 0 and there was 100 in the bank. Then, for example, I would take 35 from there, and George will have 35, and in the bank there will remain 65. Then, for example, George can take another $35, and then he will have 70, and in the bank there will remain 30. Unfortunately, we can't take any more money because we can take only 35, and it's not enough here. There is not enough money here to take. So if we want to take some more, we'll have to give some back and obtain 56 here and 44 here. Then we can take the money back again. Minus 35 gives us 91 here and 29 here, I suppose. Wait, what 29? just 9. Okay, having that, we may want to, again, we can't take this 9 because we can take on the 35. So let us move 14 back. And well, it's obvious that we can't really, if we move 14, we will obtain 23 here. It's still not enough. So I will perform this operation 2 times and actually move $28 there. Then I'll stay with 63 here and 27 here. And then the last step, let me take 37 from there. I obtain 98 on the left and 2 on the right. Okay, so we managed to take some big amount of money from the bank, nearly everything, but 2 is still there. The question now is, the question was to find the maximal possible value. Now 98 is okay, but what if we could take 99 by performing the operations in some different order? Or what if we could take 100 by performing even like the whole sum by performing the operations in some different, more clever order? So the question is, can we do that or not? And to answer this question, we have to do some kind of research around this problem. So imagine that we have performed in some order X operations of withdrawal. Then in total, we have withdrawn 35 times X dollars from the bank. And imagine that at the same time, we have performed Y operations of returning money to the bank. Then in total, we have returned 14 times Y in the bank to the bank. 14 times Y dollars. So this is the total sum that we obtain. We have taken something several times, we have returned something several times, but in total, if we performed X operations of withdrawal and Y operations of returning, this is the sum, the total sum we obtain. Now, of course, it depends whether we, not for any X and Y, it is possible to perform so many operations. For example, here you see that we could not like perform, for example, 5. X could not be equal 5 because we don't just have a sufficient amount of money in the bank. But if there are some X and Y for which we can perform such number of operations, then in the end we will obtain this value of money. So let's check whether we some way can ever obtain 100. Well, of course not, because look, this is divisible by 7. I will just write. Divisible by 7. And this too. But 100 is not. It is not divisible by 7. Hence, for no X and Y, whatever nodes there are, this equation cannot hold. So we cannot hope to design a very clever sequence of operations which will get us all the $100 from the bank. And actually the same holds for if we try to get 99. Again, this is divisible by 7 and this is divisible by 7. So hence the whole sum must be divisible by 7, but 99 is not divisible by 7, just as 100 is. So again, this is impossible. So 100 is impossible, 99 is impossible, but 98 is possible, as we have just shown. Actually, 35x minus 14y equals 98 is solvable in integers, but it is not like on its own the proof that 98 can be taken from the bank. The proof is the correct sequence of equations. So if you want to be sure, you must produce this correct sequence of equations, which gives you 98. But once you have done this, you may happily write the answer down, because you have proved this is the maximal answer you can obtain. Are there any questions about this problem? This is a bit more complicated than the previous. Why did you divide by 7? Well, I just noticed that I didn't really divide. I have noticed that this is divisible by 7. If you have an equality A equals B, then if these are the same number, then if A is divisible by something, then B must be also divisible by this something. Yeah, they're same numbers. Here we have this term divisible by 7, 14 divisible by 7. Hence the sum must be divisible by 7. It also, well, must be divisible by 1, for example, and 100 is divisible by 1. So this dividing by 1 does not lead us to the contradiction. By dividing by 7 leads us to the contradiction. So it was just like something like I noticed it. I noticed that if I consider 7, it leads to a contradiction. Hence, this equation cannot hold. Okay. So I hope that I have answered. Okay. The next problem, 17. There are 4 non-zero real numbers. So 4 real numbers, A1, A sub 2, A sub 3, A sub 4, all greater than 0. All not equal to 0. Nothing is said about them being greater or less. Just non-zero real numbers, which form a geometric progression. Okay. Geometric progression. The question is to find the product. If we are given some additional information that their sum is 15 and that the sum of their inverses is 3. Let me see if there is any question. I'm not sure about the passing grade. Maybe Hatun will answer. I don't think that there is actually passing grade. I think that all the students pass the exams and then the results are ordered, and those who have the highest pass.
Yeah, so we will publish the list of admitted students and the passing score on 28th of December. So the 14, it was the passing score for previous cohort, but it might be not 40 for next one.
Yeah. So it will be decided when all of you submit your answers and the exam is checked. So imagine that nobody have solved nothing and one person solved the first problems, and of course he will be admitted. He's the best, he or she. So yeah, we have these 2 equations, and we need to find the value of this product. Where am I? Here. Okay. What is geometric progression in the first place? If AI, A2, A1, A2, A3, and A4 form a geometric progression, this means that A2 equals some number Q multiplied by A1, and A3 equals the very same number q multiplied by A2, and A4 equals the very same number q multiplied by A3. So this is just the definition of the progression, okay? And if I'll for clarity just write just A instead of A1, okay? Then A2 equals QA, and A3 equals Q squared A, and A4 equals Q cubed A. Okay? Seems legit. But then let me rewrite these two equations. So it says that A plus AQ plus AQ squared plus AQ cubed is 15, while 1 over A plus 1 over AQ plus 1 over AQ squared plus 1 over AQ cubed equals 3. Okay? I'll just remove this because this was part of the explanation, so I obtain some more free space. Okay, but then let me reform this sum of fractions a bit. I will actually bring them to the common denominator. The common denominator will be AQ squared. And here I must, so to bring this fraction to this denominator, I multiply it by Q3 divided by Q3. So here it will be Q3 instead of 1 plus Q squared plus Q plus 1. Okay, and this equals to 3, which means in turn that it's just, wait, I will write it again. Okay, AQ cubed equals to 3, which means that this sum itself equals 3 times A times A times Q cubed. Yeah, I just multiplied both sides of the previous equation by A times Q cubed, and this is what I obtained. On the other hand, from this, I can divide both sides of this equation by A and find out that, what I'm doing, and find out that this particular sum we have here equals 15 divided by A. But we have this sum equals 3A Q cubed, and this very sum equals 15 divided by A. Hence, these two are equal. And from this, we obtain that I will multiply both sides by A and divide both sides by 3. By 3, I will get 5 on the left and A squared cubed on the right. Okay, this is information I get. Now it is time to rewrite actually the thing we wanted to compute. As we have, as it is a geometric progression, then I have A1 equals to A, but A2 equals to A times Q, and A3 equals to A times Q squared, and A4 equals to A Q cubed, which is, it's A here, which is A to the power of 4, Q to the power of 6, which is A to the power of 2, Q to the power of 3 squared. Actually, I should have done this before going into details about computing this, because when I did this, now I know what I want to find. I want to find this thing. Or if I obtain just this, I want to find something which will help me to compute this. And I have found it. So this thing equals to 5, which means that the original value is 5 squared. So it's 5 squared equals 25. Okay, this is the answer, 25. Are there any questions? How many points are given for each task as they go?
So there are 20 questions and the maximum score is 100. So it means that 5 per each task.
Yeah, I mean, but they are equal in their value, yeah? Each task
Yes.
has the same number of points you get if you solve. So
Correct.
yeah, but this means that you want to solve as many problems as you can. Okay, question number 18, combinatorics, which somebody asked about. The question is, so we have 3 letters A, B, C, and the question is how many words we can form from them. 5-letter words, which consist of 5 letters, and such that the number of A's is even. So how many 5-letter words made of letters A, B, and C are there such that the number of A's in this word is even? So for example, this kind of a 5-letter words would count. It has 2 A's. This kind of 5-letter words would count. It has 4 A's. But unfortunately, for example, this 5-letter words would not count because it has 3 A's in it. Okay. So how can we compute this number? I would suggest to separate 3 cases. So we have 5 letters. The number of A's must be even. So it can be either 0. 0 is an even number. Don't forget about that. So number of A's is either 0. It also can be 2, and it can be 4, and it can be 6 because we have only 5 letters in our word. So if there are 0 letters A, then any word made of B and C would count. So how many 5-letter words made of B and C are there? Oh, it's 2 to the power of 5. There are 5 places. And for each place, B or C goes. So we have 2 choices, like 2 choices here, 2 choices here, here, and here. And by the product rule, the total number of words we can construct is 2 to the power of 5. So it's 32. If we have 4 letters A, then okay, let's go in order. If we have 2 letters A, then again we have 5 positions. A is on some 2 of them. So a way to construct such a word would be to choose some 2 positions, put A there, and on other 3 positions, and we fill other 3 positions with B's and C's. So we first choose 2 positions out of 5. We had 5 positions, and we choose 2 of them. This is the special kind of notation you can also find in English textbook this notation, which is number of ways to choose two elements out of a set of 5 elements. Okay, so we had 5 elements, 5 positions. We want to choose 2 of them, any 2 of them, and place A's there. So there are such number of ways to do this, and there is a very very simple formula to compute this number, which in the So in general, of course, I have given an example with 5 and 2 here, but in general, you can write something like C of n and k, which is in some textbooks denoted like this. And this is the number of ways to choose k elements from the set of n elements. So here, in this particular case, in general case, it equals this. And this is actually the formula I suggest you to learn by heart for the exam. So it's better for you to know it than to try to derive it. It is possible, but not during the exam, I think. Anyway, for the case of 2, if you have k equals to 2, the formula reduces to very easy one, just n times n minus 1 over 2. So here we can use this formula instead. It would be n, which is 5, times n minus 5, which is n minus 1, which is 4 over 2. It is 10. So I'll just, this equals to 10. But I'll substitute it later. Okay, we have chosen our 2 positions for A, and the remaining 3 positions are filled with B or C, each of them. So again, there are 3 positions, 2 choices for each. It's 2 to the power of 3. So it's 10 times 8, it's 80. And the last case, when there are 4 A's in our word. 4 A's. Let me just choose the position. Okay, we can go the same way, the same strategy. We choose some 4 positions in the word. But choosing some 4 positions is the same as choosing like one position which will remain free for some time. So there are 4 ways to choose 4 positions. Because we choose one and leave it aside, and the other 4 positions are filled with A's. So there are 4 ways to choose the positions for A, and there are 2 ways to fill the remaining position with either B or C. So there are 8 there were, of course, there were 5 positions. Indeed, there were 5 positions. So there's 5 ways to choose the position which will get B or C, and others will remain, others will have A on them. So there are 5 positions times 2, it's 8. And now what we need is just to add these 3 numbers, because they refer to different cases. But in general, if you have just even number of A's, you can do that 10 ways to obtain 4 A's, 80 ways to obtain 2 A's, 32 ways to obtain 0 A's, which is 122 in total. Okay. There was some question.
There's a question regarding the online exam topic. So under which section Does to which section is connected this issue, could you please email us at our email address? I will type it here because I'm not sure that I am able to answer right now.
So if there are no questions regarding the problem, let's move further. Problem number 19. We are given a set of constraints. I'll just write them here. First constraint, 4x minus 4 greater than 4. Second, 2x plus 1 great not less than x plus 3. Second, 15 is less than 4x plus 10, but 4x plus 10 is also less than 15. And x over 3 is less than 6. Now, these are the 4 constraints. And we are asked to find a minimal, or semi-minimal maybe, it's well defined, the minimal number x, the minimal integer number, but actually doesn't matter this problem. The minimal integer number x such that at most one of these constraints is violated, such that at most one of the following constraints, following means this, is violated. Okay, anyway, let me rewrite these constraints in some more maybe simple form. So we have 4x minus 4 greater than 4, which is just x is greater than 2. We have here x is greater or less, greater or equal than 2. Yeah, I move 1 here and over the sign of inequality. This constraint means that actually 4x, let's move 10 here, it will be 4x greater than 5, which means x is greater than 5 over 4, and at the same time x is not greater than 40. And also x is less than 18. So let's look at these constraints. We must find the number such that at most one is false and all the others must be true. And we must find the minimal of such numbers. Nevertheless, let's look at this constraint. Can it in any way be violated? Well, if it is, wait, I have just put a mistake here. It's 4x not less. It's 4x less or equal than 40, and then x is less or equal than 10, of course. Otherwise, the solution wouldn't work. So if this last constraint is violated, then of course the third one is also violated. If x is greater or equal than 18, then it is for sure greater than 10. And if we violate this constraint, then we also violate this. So we can only violate one constraint at most. So this must be true. Going further, let's look at these two constraints. If this constraint is violated, the second one, then of course the first one is also violated. If x is less than 2, then it cannot be greater than 2, which means that the second constraint is also true for any possible answer. We must satisfy this constraint. But now this constraint gives us some very good information. We know that any answer we can ever hope to get is greater or equal than 2. But wait, we want to find the minimal such integer. So it can't be less than 2. So if 2 actually is okay, if 2 violates at most one of these constraints, then we are done. Then 2 is the minimal possible answer. Let's see. This constraint is violated for 2, because 2 is not greater than 2. But this is satisfied. This is satisfied for 2, okay? For x equals 2. And this is satisfied, which means that 2 is okay. And it also is a minimal possible, because nothing that is less than 2, anything that is less than 2 violates at most, at least 2 constraints. So our answer is 2 here. Actually, this whole argument about this constraint is not necessary. We could actually start with considering this constraint and come to this answer straightforwardly. Okay. No questions so far. So I hope that this is clear. So. And the very last and the most complicated, or maybe at least kind of supposed to be the most complicated problem. It states that there are 5 integers written on the blackboard. We can perform 2 operations. We can either take any 2 of them. So there are 2 operations. I will denote them by B and A. Operation A requires to take any 2 numbers, say x and y, or let's be consistent with the variant. Say it would be A and B. Let me see if it's a question. Is negative making there for wrong answers? Do you mean the problem, the previous problem? Or if it is a question about how the exam is checked. No, I think that if answer is wrong, you obtain like 0 for this problem, and that's it. You don't get any like minus points. Anyway, so there are 2 operations that we can apply to this 5 number to these numbers written on the whiteboard. The first operation takes any 2 and produces a new number equal to a times b minus a minus b plus 2. And what if we want to apply this operation to any 2 numbers, we erase them and write the result instead. So we take 2 numbers, erase them, compute this 1 number, and place it on the whiteboard in place of those 2 numbers. Another type of the operation, B, or let me denote them with maybe numbers, just the first operation, the first possible operation, and the second possible operation, is to take 3 numbers and just replace them with their product. So we either replace 2 numbers with this strange thing, or we replace 3 numbers with their product. Now the question states that there was some sequence of operations applied, and you can see that applying any operation reduces the number of integers written on your board, because you either replace 2 by 1 or 3 by 1, but the whole number of integers reduces. So after applying some sequence of these operations, there was only one remaining. So after applying these operations in some order, we obtained one number on the board. Okay, only one number remained on the board. The question is, what is the smallest possible value of this number? And I think I'll have to move to another whiteboard because this is ended. It can be on the 20 slides. So I hope that you can see the whiteboard number 2 now, which I'm writing on. So this problem is kind of complicated. I'll go back for the statement, because actually we don't know how these operations really behave. We are told that we don't know the order. We are told that some sequence of operations was performed and that one number remained, and we are asked what can be the smallest possible value. So to answer this problem, it is maybe useful to do some research about these two operations and about their properties. So I'll try to do this research now. So let's consider the first operation first. This operation takes two numbers, I will rewrite it here, and produces another number of this form. But what if I had three numbers and I have applied the first operations to the first two of them, and then I took the result and applied the operation number 1 to the result and to the number C? What would I obtain? And would it differ from the result I obtained when applying the operation in a different order? So what if I did this? Would the result change? Let's see. So if I apply the operation, so if I apply the result here, would be this. Now I apply the very same operation to this result and the number C. So I compute their product. And then I subtract the first number. And then I subtract the second number. And then I do the +2. And what do I obtain? I'll just simplify the expression. I obtain ABC minus AB, yeah, this. Then minus AC minus BC plus 2C, but minus C. Okay, let's see, plus A plus B plus 2C, but minus C leads to plus C. And in the end, minus 2 plus 2 is 0. So I obtain this result. Or I will rewrite it a bit, ABC plus A minus AB plus C minus, I just rearrange the terms, AC plus B minus BC. Now, the numbers we had on the blackboard were integers here, all greater than 2. And the thing is that if these two integers are both greater than 2, then B is greater than 2. At least not less than 2 and greater than 1. But if B is greater than 1, then this whole thing will be negative. Okay, so A times B is greater than just A, hence this is negative. And the same applies to this and this. Now look, we have here the product of the three numbers, which is actually the result of applying the operation number 2 to these three numbers. And then we add something negative to it. So when we apply operation number 1 2 times, we obtain something smaller, or at least not greater, than when we apply the operation number 2 to these three numbers. So I will highlight it. If I had numbers A, B, and C, and I applied operation 1 and then operation 1 to the result and C, I have obtained something at least smaller, or at least not greater, than if I just took the three numbers and applied the operation 2. And the question was about the minimal possible number which we obtain in the end. So if we want to obtain the minimal possible number, it is wise to use the operations which actually produce smaller numbers. So the thing is that if the sequence of the operations which is mentioned in the statement, so there was some sequence of the operation, if it contained any operations number 2, then we can replace them with operations with pairs with double operations number 1, and the result will not grow. The result of the whole sequence will not grow. So if, for example, we had this 5 numbers, 2, 4, 6, 8, 10, and we applied some sequence of operations like this to some of them, I don't know to which, and we obtain some number s, then we can replace the application of operation number 2 by 2 applications of operation number 1, and we will get the result, some y, which will be at least not great. So if we are interested in the minimal result, it suffices to consider only sequences of operations number 1. We can forget from now on about the operation number 2. If we forget about this, let's just look on this result. This result is kind of, I'll write it with blue. It's, and I hope that I spell it correctly, symmetrical for A, B, and C. So it's actually, it doesn't matter whether we use this order of performing operation 1 or this order. The result is the same. So operation 1 is as the same algebra is associative. So it doesn't matter in which order you apply it to. But, well, it actually solves the problem. We had 5 numbers. We know that we can only apply operation 1. We have thrown away operation 2 at all. And we know that we can apply it in any order we like. The result will not change. So let's do that. Let's just apply operation 1 here. For example, you can do it in any order. I just choose this order. It would be 4 times 2 minus 4 minus 2 plus 2. It will be 4. Then let me just find where I have. Then I can combine 6 and 4 using operation number 1 and obtain actually, so it would be 6 times 4 minus 6 minus 4 plus 2 would be 24 minus 10 plus 2, 14 plus 2, 16. So the result of here would be 16. Then I combine 16 with 8 and obtain 106. And the last step, I combine 106 with 10 using operation 1 and obtain the number 946. Now, the number 946 will be the same. It does not depend on the order we applied the operation 1, and it cannot be decreased further, because the only change we can make is to introduce the application of operation 2, but it will only increase the result, as we know. This means that our answer is in front of us. This is the smallest possible number we can ever hope to obtain. So I would say that this problem is more complicated than the first half of the list, because you have to, to do some research around. At first glance, when I saw it, I didn't know how to solve it at all. And for 5 minutes, I just stared at it, thinking of different calculations. But then I started to do the research. I just put the problem aside, took the operations themselves, and started to somehow try to find the properties. And when I did this for a while, I found some very useful properties which can then be applied to solving this particular problem. So this problem is complicated, and you will, well, possibly require some kind of maybe 20 minutes, 15 minutes, depending on how fast you think, to solve it. So keep that in mind. And I think that if there are any questions, I will be happy to answer them. But that's actually the end of the list. We have come to the conclusion.
Anyway, if you have any questions, you always can email us. So yeah, but now you also have an option to ask the questions regarding the problems here. But I think that we've covered everything for today.
There is a question in the chat. Hi, can I ask you, please? Ah, yeah, you have answered.
But there's a question in Q&A once again. Why is the order is not vital?
Okay, let's see. This is the result that I obtain when, so this is the result of this order, yeah? I first apply operation number 1 to A and B, I get this. Then I apply operation number 1 to the result and to C. But then I get this particular result, which is kind of symmetrical in terms of A, B, and C. If you substitute like A with C and B with A and C with B, it will be the same. So if you imagine that you have computed like, for example, first you have computed the result of applying to B and C, and then you took A and took the result and computed the general result. But then you'll have the very same picture, because if this argument by symmetry does not convince you, you can just try it by yourself. You can just compute this value. It would take you like BC minus A minus B minus C plus 2 multiplied by A, and then minus BC minus B minus C plus B plus C minus 2. I'm just rewriting the very same thing for this order. Minus A plus 2. Yeah, and then the very same logic goes. You get ABC minus AB minus AC minus BC plus B plus C plus 2A minus A, which is A minus 2 plus 2. So if you want like the real total rigorous proof, just compute it again, and you'll see that the result of it is exactly the result of this. Yeah, and it looks like this. It is symmetrical in its variables A, B, and C. Yeah, that's why the order does not matter when you have 3 numbers, but by the general rules, it doesn't matter like anywhere. It's like for the addition of a multiplication, you have the same. You have like the law from high school, which says that the operation of addition is associative, which means that you can move brackets. And this means that you can move brackets along the very long expressions in any order. So I hope that I have answered the question.
Okay. If there are no questions, so once again, Anton, thank you for the webinar. And I also would like to say thank you, all participants, for joining us today. We will share the recording of this webinar very, very soon. Once again, thank you and good luck with your exam. In case of any questions, email us. So have a good day.
Yeah, good luck. Good luck, guys.
Bye.
Bye.